Boom. Okay. Awesome, 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 awesome. So welcome everyone. If you're watching this, there's two things you should have open. That is your handout, your 2.1 2.3 handout, and you should be on September 23rd, which is page 10. Okay, and then you should also have your GIZMOS simulation open. Okay, remember, in order to access it, you will go to Clever, or you can also just search for explorelearning.com and then sign in. Okay, now let's go over our do now. Okay, for our do now, it first asks us, the first question is on the let's say on the first one, it says drag the initial, as you can see, drag the initial point, the circle of vector A to the origin. This vector is now set to be in standard position. Notice the components of A shown in brackets like this. So if we go back here, A is the blue one. So when you have your thing open, it kind of opens it like around here. So what you have to do, you have to click on the blue arrow and drag it at the center of the graph, right? Now, if you look at the top left right here, there are some coordinates, some points, right? So if you look at it, it says what, -2 and 4. You know that -2 is your x-axis, and you know 4 is your y-axis. So that means from the center point, you move 2 spaces to the left, -2, and you move 1, 2, 3, 4 spaces up, which is your y-axis. So that means for your answer right here, what are your components for A? They are -2 and 4. Just like that. They are -2 and 4. Okay? Awesome, 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 awesome. Now, let's look at the next one. It says, drag the initial point of vector A around. Drag the initial point of vector A. Okay, so if I click on the blue arrow and I move it around, how do you know if the coordinates change? Well, you have to look at right here in the top left corner. A is -2, 4. What happens when I move it? Actually, this is a little bit tricky. The coordinates don't change, ladies and gentlemen. The coordinates do not change because it's still the same. Like even if I put this right here, if I start at where the blue circle is, I move 2 to the left and 4 up, it's still -2, 4. If I move it over here, maybe to this area, it's still -2, 4. If I move it down here, it's still -2, 4. Ah, pues my bad. Someone said that I said the whole arrow, not the whole thing. My bad. You're right. I should have restated the question differently. That was my bad. Yes, but the whole yes, you said the arrow, not the whole thing. My bad. You're right. If you move the whole entire thing, sorry about that. Maybe that's why you guys got confused. But yeah, if you move the whole vector, the magnitude will still be -2, 4. The size of the vector will still be -2, 4. Okay, so it does not change. So the answer is no, it does not change. Thank you for my scholar who called me out on that. That was my mistake. I should be more specific. My bad. Awesome. Let's look at the next question. It says, compare the coordinates of the initial and terminal points of A to its components. Okay, that's just instructions. C, how can you find the components of vector A? So how can you find the components of vector A, right? Well, basically, all you gotta do is what? Start at the origin point and just move accordingly to how many times you have to move it, right? So if I move 2 to my left, that's the x-axis. If I move 4 to the top, that's the y-axis. The same thing with the B. With B, if I start at my origin point, I move 1, 2, 3 to my right, that's +3, and I move 1 down, that's -1. So what's my coordinates? 3, -1. See that? 3, -1. So always start at the origin where you start off, and then try to make it with the tip of the arrow, the tip of the vector. That's how you find the coordinates. Okay. That's how you find the coordinates. So it's asking us, drag the initial points of both vectors to the origin. We just did that. Look at that. You just drag it to where 0, 0 right there. And then it's asking you, drag the terminal point of A to 4, 0. That means 4, 0. That means we have to move 4 to the right, and then the y-axis has to be 0. So let's touch the tip of the vector and then start moving it to where it has it at 4, 0. a way to confirm that is just looking at the blue rectangle right here. It's officially at 4, 0. That means I move 4 to the right, and it's at 0. I'll move anything up. And then it says, then move the terminal point of B to 0, -3. So 0, -3. So I move this down to -3, and then it doesn't go anywhere. It just stays at 0. So your screen should look like mine at this point, at this time. Great question. A terminal point. The terminal point means the end, the tip of it. So it's another word for the tip. So the terminal point is the end point. That means I'm moving the tip of it. Because if I move the starting point, what happens? I actually move the whole entire vector. So terminal point means the tip of the arrow. Hopefully that answers your question. Great question, by the way. Okay, awesome. So let's look at what the instruction says. It says, recall that all vectors have magnitude, length, and direction. I'm actually going to stop here real quick. I'm going to give you 3 minutes to work on that first one, that first question. You see the one that's highlighted? I'm going to give you 3 minutes to work on A, B, and C, okay? If you have any questions, please let me know. Okay, let's check this out. So for A, it says, use north, south, east, or west to give the direction of A and the direction of B, of vector A and vector B. Well, we already did it, right? We already have our directions right here, right? Look at this. So A, what direction is A showing? And I see some people have actually private messaged it. Thank you so much. Yes, so I'm getting some common answers. A is going east, right? Remember, north, south, east, west. Never eat slimy worms. Going like a little clock. Never eat slimy worms. So you always go north is up, east is to the right, south is down, and west is to the left. So according to vector A is going towards the east, and vector B is going towards the south. Good job on the ones who answered it right there on the chat box. So A is south, east, my bad. A is east, and B is south. Good job. Okay, east and south. Okay, because of the direction. Remember, vectors always have directions. Now we know they have direction. Now, what kind of magnitude do they have? That's B. We know vectors are both magnitude and direction. So we know A we already gave it a direction, but what's the magnitude? So it says the expressions of A and B represents the magnitudes of A and B respectively. So find the absolute value of A and the absolute value of B. Those little lines you see, those are absolute values. So I don't see anyone, I don't see a lot of people answering on B. But if you look right here, oh, actually I have 2 people answering. Yes, some people put 4 and some people put 3. So if you look right here, the coordinates of A is 4 and 0. So what you gotta do, you have to add them together. So 4 plus 0 equals what? Equals 4. So the magnitude of A is 4. Good job. Shout out to Zariah on that one. Good job, Zariah. Oh, there you go. 4. And then for B, you have to do the exact same thing. You have to add them together. So we go back, value means that you get rid of the sign. So 0 plus -3 is -3. But since it has the arrows, the lines between them, you get rid of the negative. So it's actually 3. So the magnitude is actually 3. Okay, remember absolute values, they get rid of the signs. They get rid of the negative sign. So 0 plus 4 is 4. 0 plus -3 is -3. So I'll do it like this. 0 plus -3 equals to just 3. Okay, because it gets rid of the minus sign. Okay, -3, which equals to just 3. Okay, hopefully that helps you guys out. And the last one is asking us, select show ruler to open the GIZMOS rulers. Attach the donuts to the initial and terminal points of the vector to check your answers. You could check your answer if you want to do that. So if you do show ruler, and if you do like this, look at that. The magnitude is what? The length is 4. If you did the exact same thing for the other one, drag the arrows And look at that, 3. So that way you can confirm your answers, okay? So you can use the arrows, the rulers to confirm your answers, okay? I'm going to get rid of this now because it's a little bit distracting. The last one's asking us, the magnitude of a vector is always positive. So as you can see, these numbers are always positive. Why do you think they are positive? Thank you for the ones who participated. I really appreciate that. So I'm getting some answers like, I don't know, which is okay to not know. Because we only think about how fast it's going, not the direction, maybe. It's a pretty good answer too. Maybe because they have a direction. So some of those answers are on the right track about direction. So the reason it's always positive, when you go somewhere, right? Like I'm going to drive 30 miles north. You always say it as a positive number, right? 30 miles north, or take 10 steps to the left, or take 20 steps to the right. It's always a positive number. Okay, it's always a positive number. You don't say take negative 30 steps left. You don't say that, right? It always by default, it's always a positive number. So the reason for this is, oh, my bad. Oh, my bad. The reason for this is, why is this true? Magnitude is a distance, which is also known as a length, aka length. Okay? And those quantities are always positive. Okay? So magnitude is there you go, is distance, or also known as length, and those quantities are always positive. When you go towards a distance, it's always going to be a positive number. So think of distance as always a positive number. Think of distance as always a positive number. Awesome. We're going to skip number 2. We're not going to do that one, just for time's sake. Let's go to the next guided practice, activity B. Okay, let's go to activity B. Awesome. So let's look into our gizmos. So we need to drag our arrows to 0 and 5, and then our vector B to 0 and 2. So vector A is 0, 5, and vector B is 0, 2, 0, sorry, 2, 0, my bad, 2, 0. So your screen should look like mine. Let's answer the question. Let's spend maybe, let's do for the first one, let's spend 3 minutes working on the first one. So let's spend 3 minutes working on number 1, which is 1 through D. Yeah, so spend about 3 minutes working on those ones, okay? Awesome. Let's go over the first one right here. So it says, for activity, it's turn off show with the initial points at the origin, change A to 1, 3, and B to 4, 2. Do that. Change A to 1, 3 would be maybe this. There you go. 1 to the right and 3 up. And then for B, it says to change it to 4, 2. So it should look like this. Your screen should look a bit like that. What do you expect the components of the resultant to be? So let's see. Let's look at the resultant. Let's turn on the resultant. Okay. So show resultant right here, right below the blue and green rectangle on the top left. Click on it. Boom. Look at that. Look at that. Awesome. I see some people have answered 5 and 5 because you add them up. That's a very, very great answer right there. Basically, yes. The reason 5 and 5 is because you add the 1 from the x-axis on A and the 4 from the y-axis of B. So 1 plus 4 equals 5. And you do the exact same thing on 3 and 2. Yeah, I'm kind of lagging. The internet has been, for some reason, right now, the internet went kind of bad. I could cut off for a bit. Yes. So only this looks though, because all the tails of the vectors are all the same, and I don't want that. So let's change this A. Let's drag it, or let's drag it to the tip of B. So like this. It should look like this, or it can also look like this. whichever way you want, as long as the A and B are doing tip to tail and tip to tail, and then result vector C should be all the tail ends and the ends of this one. So it should look like this. That way it looks better, look prettier. Because if you do it like this, you did the original way, it won't look that. It doesn't look that well. You can actually follow the path. So make sure you always create a path for that. Okay. So it should look like this. Always tip to tail, unless it's the result vector that's going to be the tail ends and the tip ends together. Okay. So, like when I started, said, what are the resultant vectors? It should be 5 and 5. 5 and 5. In general, how can you use components of A and B to find the component of C? You can basically add together. You can add the coordinates together. Yeah, I'm definitely lagging so much in this typing as well. So in this case, we have A, which is 1 and 3. And you have B, which is 4 and 2. So they do just add them. One plus 4 and 3 plus 2. And what does that give us? That gives us 5 and 5. Boom, right there. Okay, 5. Yep, I am. I'm lagging. Oh my word. Where did you guys stop lagging? So we're going to stop right now. So you can continue to work on it if you want to. But for today, you have one thing to do, and that is your assessment questions. That means if you go to your GIZMOS, go all the way down, and there are 5 assessment questions. Just complete them. Okay? Complete them. Just to see how you're understanding on this simulation. Okay? So once again, I'm stopping right here. Do the 5 assessment questions by scrolling all the way down from your GIZMOS simulations. You should have your assessment questions here. So no, you don't have to complete the GIZMOS. Remember, the handouts are there to just help you. So you can complete the handout if you want to, but you don't have to. So the only thing I want you guys to do is just complete those 5 assessment questions, okay? So once again, don't need to complete the handout for your own benefit if you want to get more practice, but please do complete the assessment questions, okay? Awesome. For my people watching this on your own time, got you guys there. I'm about to finish this. Goodbye. Adios.